right, so today we got a follow-up from 2.4, still dealing with linear stuff. So we're going to talk today about equations of lines. How do you write those equations and what are the different forms? And then look at some linear models as well. Maybe some review today. Let's hope. So first of all, we have three different forms that we use to write the equation of a line, and each one kind of has its own purpose. So you sort of need to know all of them. We've got our standard form. I think of this as, oh, it looks pretty because A, B, and C are integers. There's no fractions, no decimals in this. We usually like to keep a positive, just have that X term, that coefficient, so that as you're writing this, that first term isn't negative. Again, just trying to make it look pretty. Works great when you're dealing with systems of equations. All right, slope-intercept form is probably the one you're most familiar with, that old y equals mx plus b. This is great for graphing. It's because you've got your y-intercept and your slope just sitting there for you. And then we also have point-slope form, and this one is used a lot when you're writing equations of lines, because what you need to have is a point and the slope, and then you can write this equation. Now, typically what happens is this y stays put, and you can kind of even see the point is x1, y1, so you're replacing the x1 and y1 with numbers, but then the other x and y stay put. We're going to practice with all of these forms here today. So let's start with, I just used some abbreviations here. This is point slope form. So we're going to use point slope form to take this information. And it looks like we've got a slope of 3 and we have a point. Well, that's exactly what you want for point slope form. So remember that you're going to take y minus y, but you're going to grab the y from the ordered pair. So it's going to be y minus -2, which turns to +2, equals m, which is your slope. We know that's 3. And then x minus the x value from your point. So that right there is point slope form, and you're done. It doesn't look real nice, though, so oftentimes we'll sort of clean it up, and we'll turn it into slope-intercept form. So I'm going to go ahead and, so this is your answer. If that's all they want, you get to quit. But if I want it in slope-intercept form, I'm going to go ahead and distribute to get rid of the parentheses. And then I'm going to subtract that 2 over to isolate the y. There's our slope-intercept form. All right, and then the third one is to rearrange this and put it in standard form. And sometimes you'll see it called general form. So know that those are the same thing. Standard form, general form means the same thing. Now, I already like that there's no fractions in this, so that part's good. I just need to rearrange it. And when I rearrange it, I want the x and the y to be on the same side and the number on the other side. So you could do that a couple ways. We typically have the x and the y on the left, so I could subtract the 3x. I'm going to go ahead and do that. I'm going to subtract the 3x to the other side, and then I would have this. But I don't love that the x is a negative, so what we would do is we would just multiply through the whole thing by a -1, which is just going to change all of the signs. So there's our nice standard form. Now, another way that you might have done that is you might have opted to subtract the y to this side and add the 5 to that side. You still would have had 3x minus y. And when you added the 5, you would have had it equal 5. So whatever makes sense to you. All right, we're going to try the same thing. Practice with all these forms, but I'm not going to hand it to you quite as nicely. Instead of me giving you the slope, I'm just going to give you 2 ordered pairs. All right, so that just means you have to go use your slope formula and you have to find the slope first. So remember, your formula to find your slope is just going to be your y minus your y over your x minus your x. So it doesn't really matter which one you start with. I guess I'm going to start with the 2. So the 2 minus the 3. There's your y minus y. But you have to be consistent. So now I'm going to do x minus x. So I have to start with the same point. So I'm going to do 4 minus 1. Looks like I end up with a -1 over 3 for my slope. So now I'm ready to do point slope form because I now have the slope. And I actually have 2 points, and I get to just pick whichever one of those I like. I'm just going to use the 1, 3. Numbers are a little smaller. So using the 1, 3, and the slope that's negative 1/3, we'd end up with a y minus the 3 from the point equals your slope, negative 1/3, times x minus, and the x from your point is a 1. Now, if you had opted to use the 4, 2 instead of the 1, 3, then your point slope form is going to look different than mine. And that's okay. It still would work. Now, it's hard to see that they're actually the same, though, when you have different numbers in there. And so that's why, again, oftentimes we'll go ahead and convert that into slope-intercept form, because regardless of which point I would have used, slope-intercept form would merge into the same with those 2 different equations. So again, all right, so here's my point slope form if that's all they want. And then I'm going to distribute. So now I'm battling some fraction stuff here. And then I'm going to have to add the 3. Now, when I add 3 to 1/3, now you might just do that in your head and call it 3 1/3, but we don't deal with mixed fractions. So another way to look at it is to add a 3/1, but I'm going to write it in terms of thirds. So that's really a 9/3 would be the same thing as a 3/1. So then my answer here for slope-intercept form would be y equals negative 1/3 x plus 10/3. Right, so now for standard form, remember, no fractions allowed. So the first thing I want to do is I want to get rid of those fractions. So I'm looking at what the denominators are, and it looks like I'm going to get lucky here. I feel like if I just take everything times 3, then I'll get rid of the fractions on that. So that's going to be my game plan. I'm going to take everything times 3, which is going to get me a 3y equals negative x plus 10. Now, I should have thought about that before I multiplied everything by a 3, because another option might have been to take everything times a negative 3, because that could have gotten rid of my negative here. But it's always smart to kind of think ahead. What's your next step going to be? Well, I'm going to be moving that x over to this side. So I really prefer it to be negative because I'm going to add it, and that's going to keep it positive. So I'm going to have a positive x plus the 3y equals 10. And that is my standard or my general form. Looks really pretty. Okay, so those are kind of practicing, getting familiar with all the different forms that you need to know. All right, so we're still going to be writing equations, but this time I'm going to be giving you different things. So in this first one, on example A here, I've already given you the equation. I just wanted it in a different form, which we kind of already were practicing there earlier, but I never went this direction. I'm going to give it to you in standard form, which looks pretty, but I want it to end up in slope-intercept form, which sometimes is more functional. Now, slope-intercept form just means you want this to be y equals mx plus b. So you're isolating the y on this. My first step would be to subtract that 4x to the other side. When I subtract that 4x, I do like to put it on the front so it'll look like that mx, and then the minus 10 is my b there. And then again, trying to isolate the y. So now I'm just going to divide everything by negative 5. So I'm left with a y equals, the negative divided by a negative will end up a positive 4/5 x, that's your slope. And then again, a negative over negative is going to end up a positive 2. So that's the slope-intercept form of that equation. All right, another thing that we might do is be given a graph and try to write the equation. So all you really have to identify is that y-intercept from the graph, and then count your rise over your run to get your slope. So looking at this example, first thing I see is that it has a y-intercept right here at 3. So that means the b is going to equal 3. And then I'm going to find another clean grid point. I kind of think this one right here is the next clean grid point. So then my slope is going to be rise -1, run 2. So my slope is -1/2. Once you know those two things, you just write your equation in slope-intercept form here. Y equals -1/2 x plus 3. Okay, you give the next one a shot. See if you can identify those two parts. Write your equation in slope-intercept form. All right, be careful with that. That y-intercept is actually at -4. It's not at -5. Count that down. So my b is going to be -4. Looks like my slope is rise 3, run 1. So I have a slope of 3. So my equation would be y equals 3x minus 4. Okay, the last one here is one of those special ones. If you'll recall from yesterday, we use this little acronym to help us keep track of this, HOI-VUX. This is a horizontal line, so I'm using HOI. Horizontal lines have 0 slope, and their equations are always just a y equals a number. There's no x in horizontal equations. So this is just going to be a y equals, and then if you look at this horizontal line, what do the y values for every spot on this end up being? 2. There's your equation. Y equals 2. All right, so the last thing we have to talk about here is parallel and perpendicular lines. So if you can imagine parallel lines, they never intersect. So, two parallel lines, since they never intersect, their rise and run is going to have to be consistent. So they're going to have the same slope, always. Now, perpendicular lines, so I'm going to just scribble that out. Think of perpendicular from geometry. Perpendicular maybe goes that way, and then you have one going this way, and it creates this right angle. Okay, so perpendicular lines do not have the same slope. In fact, you will always have one line that tilts to the right and one that tilts to the left. So that means that they are going to always have opposite signs. But not just that. Do you remember the other part? They're also reciprocal slopes. So you have to do the opposite reciprocal slope on perpendicular lines. So it says write an equation of the line passing through this point, 3, -5, and it's going to be perpendicular to this given line. So they gave me a point, and ultimately they're giving me the slope, because if it's perpendicular to this, I'm going to figure out what this slope is, and then I'm going to do the opposite reciprocal on it. So then I'll have a point and a slope. Final answer is going to be in standard or general form, but we're not going to start there. Let's go ahead and see if we can figure out what the slope on this one is. Now, maybe the easiest way would be to put it into slope-intercept form, so the slope is sitting in your equation. So I'm going to take this. I'm going to start way over here because I'm going to have several steps on this problem. And I'm going to start isolating that y. So that means I'm going to leave the 4y on the left, but I'm going to subtract the x. I'm going to add the 8 to the other side. Then I'm going to divide everything by 4. So I have y equals, this ends up being like a 1 assumed to be right here. So it's a -1/4 x plus 2. Now, the only thing I am going to use for this is this slope right here. Don't think you need that 2 for anything. It does not matter. The slope of this line is -1/4. But I want the perpendicular slope. So I'm going to do a little notation from geometry. Remember that upside down T for perpendicular? So the perpendicular slope is going to be the opposite reciprocal. So that'd be a +4. That's the slope I'm going to use. And then they gave me this ordered pair, 3, -5. Notice again, it's point and slope. So I'm going to do point slope form. Y minus the y value, so that's going to turn to +5. equals, the slope I want is a positive 4, and then x minus the x value. Okay, that's point slope form. They want standard form. So really, to get to standard form, I'm probably going to go a little bit through the slope intercept form, because I definitely am going to want to distribute and get rid of parentheses. So I'm going to have y plus 5 equals 4x minus 12. All right, so I'm going to move my 4x so it's over on the left side. So it's going to end up negative when I do that. Negative 4x plus the y. And now what I also want to do is I want to take this 5 and I'm going to move it over to the other side with that negative 12. So I'm going to subtract 5, which is going to get me a negative 17. But we do like that first term to be positive, so I'm going to go ahead and take everything times a negative 1 to make it positive, or to change those signs. And this is going to be the standard form then of that equation. All right, so that's just kind of some different things about writing equations of lines. Hope this helps. See you later.